This is joint work with Charlie Murray and San Tian and Yi Zhou. We want to talk about intermediary used car market. In the used car market, it's something we call search friction because people live in different places. Car dealer help us to find a focal point so that we don't have to go drive around driving in each seller's office or his home. They also help us to select better good. If they hold a high standard, we can only go to a small number of dealerships so that we can find a better product quickly. So they create surplus in the language of. What else they do? Well, the other picture is not so bright. They also charge us high price. They also because of it's so convenient to trade in dealership, they also crowd out the private transactions. With dealership, there's no point for most of people to go to each of the seller's office or home and then directly buy car from them. So in other words, they may extract surplus from transaction by charging high price. They may redistribute surplus between a seller. And there are many channels dealer may affect the market equilibrium and consumer welfare. In this paper, what we're going to do is trying to characterize the welfare impact of car dealers and decompose them into several novel economic channels. Right? So what we're going to do is that we want to have a spatial bargaining and search model. In that model, there will be search friction and a dealer going to have advantage in search and matching. They're going to hold a higher standard to select better cars. So as a result, they may charge high price because they sell things better and faster. And also we allow dealer to have different bargaining power than private sellers. So maybe part of the reason their price is high is due to the bargaining power difference. We are trying to decompose the welfare impact into those channels and trying to give a more comprehensive evaluation of our dealers. To do that, we need a structural model. So let me give you a brief preview of our result. One, car dealer is important. Even if we just reduce 10% of car dealers' capacity in the market, it's going to cause thousands of dollars of welfare impact on consumers and the sellers. And you also see if you take out 10% of this dealer capacity, all the remaining dealers' profit going to increase. So this probably tell you there are too many dealers in the market. Then the conclusive result. Second, we find that empirically, dealer has multiple important advantage in bargaining, search and matching, and part of the reason they are able to charge high prices because those advantage. And naturally, we don't like them, so we try to see if we reduce each dimension of their advantage, what's going to happen? Well, what's going to happen is that dealer are going to be less happy. They will be less willing to participate in the market because they are still more efficient transaction channel than private transaction. And this shifting of transaction from more efficient channel to less efficient one going to hurt the consumer. If the consumer being hurt, they are more vulnerable from surplus extraction. The equilibrium price actually going to go up and consumer welfare may go down. The last one is that we want to think about what will be the impact of reducing search friction. And in this particular market, search friction emerged because people live in different places, because there is a spatial heterogeneity. But information technology development tell us that over time, the distance become less relevant because we have visual, we can have visualization on dealers' website. We can see cars even though we don't get there. Maybe distance become less relevant. We're trying to understand those reduction of search friction in the environment, how it's going to competition, and how it's going to affect consumer welfare. Conventional consumer search model tell you if you lower the search friction, that's going to make product more homogeneous, going to intensify the price competition, and consumer will be better off. That's not the case here. When you reduce the spatial search friction, private seller will also find themselves in a better position to trade by themselves. They have less reason to rely on the intermediary to trade their cars, and they will be less willing to trade through the dealers. But still, even after the reduction of the search friction in the environment, private transaction sector is still less efficient than intermediary transaction. The shifting amount of transaction volume from intermediate to private market overall in the equilibrium gonna make the search friction in the equilibrium higher than before, even though the search friction in the environment by parameter was actually lower. That's gonna hurt the consumer, increase the price. That challenged the conventional wisdom we have by using standard model with single transaction channel. All right. So I'm not going to spend much time on the literature because I only have 30 minutes. But roughly speaking, there are two ways to think about intermediary, and depends on different type of friction, depends on different function they have. One is based on search frictions. People have a hard time or costly to find each other. And dealer exists because they are better in search and matching. Theory paper and most of the empirical papers in a reduced form or structure are based on this sort of friction and work on that. There's another group of research emphasize that the dealer's role is to select a better product. And most of the paper in this literature actually ignore search frictions, and because they are written by game theorists. And typically friction, people assume there is asymmetric information. All right. And most of the research are theoretical. There are some empirical papers. And what we're trying to do is trying to bridge two literatures. We're trying to find a framework that incorporates both dealers' role as selecting better product and also overcome search friction. And we also introduce heterogeneous bargaining power and trying to really decompose different channels' welfare contribution. Okay? And the methodology we use, the model we built, shares some similarity with labor search literature. So I own a lot of debt to people here because I learned most of my search model from those people. Let me briefly talk about the data. Used car market is big in the US. A lot of people buy them. Used cars are super heterogeneous, more than new cars, because not only cars are different, but also they have important dimension, their age. It turns out to be one of the most important factors that affect the car's value and their transaction price. And this market is quite frictional because, you have to go there and see the car, do the test driving, and then you have to find the time that your boss is okay for you to go there. Oftentimes, it takes weeks to trade. And oftentimes, your home is not very close to the dealership. It's far away. Imagine you live in a small college town. There are only two dealerships. It turns out you don't like their cars. And most of the transactions are determined by negotiation. You go there, you see the car, and you bargain over the price. There's some trade through dealers. There's some trade between seller and buyer directly. Our focus is Ohio, and particularly in Columbus area. So we pick a spot because it's computationally so challenging for us to look at the entire Ohio market. And it seems ridiculous to us to trade this as an integrated market because from here to here is really far away. So we focus on this area with 7 counties. This is where University of Ohio State is here. This is the Franklin County. And there are several smaller counties. When I say small, I mean population size. There are a million people live here. Here is more like thousands of people. And this area is buffered by a lot of extremely low populated counties, you can basically ignore those counties' transaction. It's pretty much as it feels. And there is another center around Cleveland, but we see from the data the transaction between those are limited. So most of the transaction you can think of are within this area. So we have two data sets. One is the DMV. DMV is the place, if you purchase a car in the United States, you have to register your car and tell them every detail of your transaction, including where you live, all the car's information, transaction information, and seller's identity. What's the dealer? If you purchase from a seller, what is the seller's zip code, where the seller lives? So it gives you a lot of information about the transaction and each party of the transaction. The other data set that we have is from a website called cars.com. It gives you the real-time information of all the dealers' inventory in principle. So registered a account on cars.com is not expensive. So if you're a dealer, it seems a dominant strategy for you to register and update your inventory over there in real time. You go to the website, you see picture of all the cars in the inventory, and you see all the price and color, all the detail. The marginal cost of updating inventory is almost zero, so you should do it. I say in principle because we never know, people could be lazy. So when you see this, you see this is pretty much a transaction matrix of inventory. You see when the car is there, how long it stay in dealer's lot, when they disappear and when they come. The other end is the transaction, right? The retail transaction. Whenever it disappear, if it's purchased by some consumer, I'm going to see that in the DMV. Given this data set, it seems very natural to have a search and matching model to rationalize it. So we built this sample by using non-luxury cars, four-door sedan, and we killed the extremely young car because in the US, typically people lease cars. If you lease a car for 3 years, and then you're gonna return to the dealer, and dealer gonna sell the car with some certification pre-owned car with some manufacturer warranty that will extremely increase the value of the car. But we want to tease that out because we really want to focus on the contribution of dealers overcoming search friction and the selection instead of providing the warranty. So we work on age 4 to 13 because after that car becomes super old and we don't see many transactions through dealer. And some facts. One, dealer typically trade cars relatively young and private transaction are older cars. I'm not going to give you the number, but you see the picture. And the average price of cars traded by dealer are substantially more expensive than the same car controlling everything you can observe from the sample, from the data, is than the private transaction. This price gap, we call price premium option. That price premium depends on two important factors, mainly. There are other things, but in this table, I show you the most important two factors. One, car age. Two, what type of dealer you are. You're an independent dealer, in their yard, there are 10 cars. Franchise dealer, they sell Toyota and Honda or BMW, they just sell a used car in those brands. And there's this CarMax, which is super big car dealership, and they have a large fraction of market share. You can control other things like mileage and colors, whatever AC, but it doesn't explain too much. This big difference of price between the dealer and the seller's car still exists, and then it doesn't shrink much. And you can look at this pattern. You see each age group, dealer's car price difference comparing to the private seller could be thousands. And then when the dealer become bigger, in the sense from independent to franchise to CarMax, the price premium increase. This is true for each age group. But if you fix each seller's identity or dealer's identity, when car gets older, price become lower. This is not surprising. But another thing is interesting is that we also document the times on the market of cars for dealers, because private sellers don't register on cars.com, so we don't see their inventory. Okay, and what is interesting is that we see when the time is on the market, if you fix each age group, when dealer become bigger, times on the market decrease. So bigger dealers have better, seems like selling cars faster. But then if you fix the identity, you realize the time on the market actually goes down when car gets older, which is a little bit counterintuitive because we thought, who's going to buy an old car? Right? So it should be slower. But it turns out when car get older, it's sold faster. This is quite interesting because we think about the price and the time on the market combination. If we look at this fixed group across dealer identity, right? Price go up, time on the market go down. But if you look at this over time, price go down, time on the market also go down. So the heterogeneity cause the car's price and time on the market differ across dealer type or across time, across car age must be different. Okay. And finally, we see that in the data, there is this network structure. So you have multiple counties, they trade between each other. This is the transaction volume. And each of the entry in this matrix tell you the transaction between those counties. And obviously it has to be asymmetric. From Hong Kong to Macau or from Macau to Hong Kong, those are two types of transactions. And you see the diagonal tell you the transaction within county. Most of them happen within county, but there will be also a cross-county transaction, but most of them happen between Franklin, which is the center, and other counties. Other small counties barely trade with each other. Yes. I don't. I only see the retail transaction. It would be great if I can see that. Yeah. Exactly. Yeah. It's too bad we don't see that. So cars in poor county sold faster. As the theorists in this project, I tend to talk about the model less. One page. So there will be vertical and horizontal heterogeneity of cars. Observable characteristics is car's age. That's what we model. Oh, sorry. And unobservable to economists are the car quality. We say high and low. When I say unobservable, that's only to us, but to other people in the game or in the model, they see everything whenever they see the car. There's no asymmetric information. There is only unobservable heterogeneity. But car dealer will still play a role in quality selection. We'll see why. There are multiple locations, 7 of them, each county has one. A buyer has a unit demand. If you purchase a car, you get some utility. Well, use the price, you hate it. And you get some utility from owning the car. The utility depends on first term. This is a depreciation effect, depends on how old the car is. The second term depends on the car's quality. Is it a high quality car or low quality car? And then there is this idiosyncratic random term. Just want to give you a logistic transaction probability. But we assume the parameter of the logistic distribution depends on car age, right? So if you think about the search model, this dispersion typically capture the wait and see effect, the option value. If the dispersion is big, you have more incentive to wait for the better realization. But if the dispersion is small, then you have little reason to wait. You're probably going to trade faster. We have different type of dealers, and each type of dealer has their mass, locations, and the inventory cost given. Those are the parameter we have to estimate. The cost is the parameter, but the measure we can observe from the data. It's a continuous time, infinite horizon search and matching DMP type of model. Or Rubinstein, Walensky, Duffy, or Alessandro Gavazza, depends on which type of literature you belong to. People are going to meet with some Poisson rate. There's a search matching function. And then that Poisson rate depends on people's location, if you two people who live in the same county, it's more likely they're gonna meet. If they are cross county, it's less likely. It depends on buyer and the seller's identity. Buyer and the dealer are more likely to meet. Buyer and the seller are less likely to meet, right? Presumably, but we allow that to be the parameter to estimate. And whenever two parties meet, seller buyer, dealer seller, when they meet, they observe the car's information and the realization of the utility, they start to do Nash bargaining. This is very important because I don't have to deal with the asymmetric information bargaining at the theory. I have to deal with that all the time. But now I'm doing empirical. I have to pick them out. Very good. Yeah. For owning the car. Yeah. But search matching this utility will be different. Right. That will be captured by the quality selection. We can have the dealer have selection of high quality car to capture this, fix the car a little bit. Observationally, you can't distinguish moral hazard and estimate. You can't distinguish that in a selection. All right. So we assume that the bargaining power also depends on agent's type. And then whenever seller and buyer get their car or sell their car to leave their market, and then someone else is going to come over time and every period. So we're going to focus on the steady state equilibrium, which tell you that in each location, for each type of agent, their measure will be constant over time. Okay. Why there is a selection? Well, it's clear that there may be search friction. There may be advantage for the dealer to overcome search friction. Well, the dealer has incentive to select better product because you have a limited capacity. It's exactly the same story in labor search. I have limited capacity. If I order the car today, before I sell it, in the future, if I see better car, I can't acquire it. So I better make sure that the car I acquire gonna bring me enough profit. Then I'm gonna sacrifice my option value by future cars. So that gave me the incentive to push my bar higher. More likely, I'm gonna trade high quality car. Even we have symmetric information. Right? So this is the transaction flow. This is the location one. Seller have car, they enter the market, they can either directly trade with buyer in the location, or they sell their car to dealer and dealer sell to buyer. All people can do this across locations with different search matching technology. All right. Estimation result. There will be depreciation for each type of cars. Low quality car, high quality car. There's a big utility difference by owning the car for the entire life. And then the value going to depreciate when the car get older. The fraction of high quality car on the market will depends on car age. When car get older, it's more likely you're going to see a low quality car. We estimate the bargaining power between seller and the buyer. This is seller's bargaining power is 60% roughly. But if you look at the independent dealer franchise, their bargaining power become higher. CarMax almost entirely extract the surplus. And you can also see the within county search and matching efficiency, and the one seller is lower, but dealer can become buyer. But all those within county search matching efficiency is going to be higher than the across counties. And you can see that dealer has advantage in search and matching, especially for transaction across counties. And here we estimate the selection. So and the search matching speed. And this is car age group, and this is the time on the market for each type of dealer and the seller. Those are pretty much just data because we can observe time on the market, but we don't observe sellers' times on the market. So this is from the estimation using the equilibrium condition. We have sellers' time on the market, which is going to be longer, so it's more frictional. And for selection, this is private seller's car quality. The probability the private seller's car is high quality, but you see For dealers, they hold a higher fraction of high quality cars for each age group. Only have time to talk about probably, okay, I have 2 minutes. I'm going to do some counterfactuals. One is that I will try to reduce dealers' slot, trying to quantify how important they are. It's going to be difficult to shut them down entirely because in this model, dealer take into account of 60% of transaction. If you kill them all, the model gonna explode. Things gonna become crazy. So we do some relatively small intervention. So this is by reducing the dealer's capacity gradually. For each graph, this W is the fraction of dealer's capacity I'm reducing. So 0 means I don't reduce any from the data. And 0.2 means I kill 20% of the dealer's capacity. And then I get higher. And here we have what? We have buyer and seller's value, retail price for average price for private transaction and intermediate transaction, and agent's total stock, time on the market for each transaction group. So you can see that when we kill dealer, consumers' expected value in the market go down and seller become better off. This is intuitive because when you have less seller, people have to rely on, when you have less dealer, you have to rely more on sellers. Seller will have better bargaining position. They feel better, they can charge higher price. When the seller's price become higher, the general equilibrium effect gonna push up the dealer's price. So consumer gonna be worse off. And the next one is that we lower the dealer's bargaining power because they have too much. And when you do that, gradually you realize from here, the price go down a little bit because you lower that guy's bargaining power. But eventually dealer will be less willing to participate in the market. They will quit. And most of the transaction have to happen between seller and the buyer. The price go down, go up, consumer become worse off. Okay. Last one. I reduce the search matching friction across county by 20%. What happened is that when that happened, if you reduce the search matching friction, seller will be more likely to trade by themselves, as I said, and then there will be less transaction through dealers. But because seller sector is still relatively less efficient, the price going to go up and the consumer welfare going to go down. And that generate a counterfactual, counterintuitive counterfactual result. Means there will be competition effect, which is standard, that's going to drive down the price, increase the consumer welfare. But there is this reallocation effect across the sectors that's going to let the seller bypass the dealer and increase the retail price, hurt the consumer. All right. So what do we have? We build an estimated spatial bargaining and search model trying to evaluate dealers' welfare in the used car market. So we quantify dealers' impact and decompose it. This is tractable spatial search and matching framework. And we get some counterintuitive. All right.
Oh, hi, everyone. It's a great honor to be here and deliver one of my recent research with all of you. My name is Jia Shen. I'm from Renmin University of China. This paper is co-authored with Pei and Yilu, and Yilu is my advisor. So my paper is about managing policy pre-announcement. In fact, in our daily life, or for example, if you look at newspaper from the Wall Street Journal, you will see some very standard examples about pre-announcement. For instance, if the Fed wants to tell the market that they will rise or cut interest rate in the future, they will just a pre-announcement, pre-announce their plan many days before their implementation. There are even many more cases in in different kinds of pre-announcements. Some policies is pre-announced to expire at a specific date. For instance, the first example, there's a row here. The American Rescue Plan just ended December 31, 2021, but it is announced to the market at March 11. So considering that there is so many examples in our policy implementation about the policy pre-announcement, a crucial question is about should we give the market pre-announcement? Will it influence the policy's effects? In the past, there are many debates on the pre-announcement. For instance, some scholars in their research paper, they show that if the market have pre-announcement, it can reduce volatility or enhance policy effectiveness. But some other counter examples or research papers also propose different ideas. They think with pre-announcement, the market will speculate for example, the benefits of the policy. So it might not always improve the policy's effectiveness. So in our paper, we want to answer two questions. One is that should we give the market pre-announcement or not? And the second is that if we should give the pre-announcement, how many months in advance should some policy be announced to the market? So in our paper, we do some literature review, and we find that in the past literature, option value theory usually gives some insights on how to understand the influence of pre-announcement to people's behavior. In the options value theory, they think that if you give the market some announcements in advance, households will have longer time more options or opportunities to make their best choice in duration before the policy's implementation. But recently, some counterexamples show that agents are not as rational as we had expected. For instance, some people may not be perfectly rational because of behavioral frictions, and people will tend to forget about the deadlines of the as the pre-announcement increases. And also, Column in their 2016 paper, it shows that reminders can further enhance the welfare. So in our paper, I want to highlight two kinds of mechanisms that determine the effects of the pre-announcement. One is our focal mechanism, that is the limited memory effect. This mechanism shows that households or consumers in the market may be paying attention to future policy implementation, even if they get the pre-announcement from the government. And the second one is standard, that is the option value effect. If households get pre-announcement, they have more opportunity to best decide their demand for some other decision. And the balance between the two forces will yield an optimal time to release the pre-announcement. Okay, so how do we expand or execute our research? We base our research in the context of China's auto industry. This is because that China's auto industry, there is many different kinds of policy variations, some with anticipation of pre-announcements, some just have been implemented exogenously. For instance, our advantages of setting is listed here. The first one is in China's auto market, especially during our research window, there is an exogenous tax cut. Such an exogenous tax event will just help us identify standard price elasticities that is very important to the classical demand response to certain policy. And in our research window, the government also gave the market some pre-announcements and anticipation about future tax rises. And the length and duration of the pre-announcement varies very large during the two tax rises. So the three times of tax policy variation helps us to distinguish the two forces. I mean, the first help us to identify the option value effect, and the future two pre-announced tax rises can help us identify the limited attention and limited memory parameters in our model. Okay, and the second and third advantage of our setting is that China has the largest auto market, so the experience joining our market may be suggestive to other markets as well. Okay, so to give a full, complete work on the research, we just use a dynamic discrete choice model here. And we also give the micro foundation in our dynamic discrete choice model by embedding the option value effect, limited memory effect into it. we not only prove that there exists a unique optimal time to release a pre-announcement, and also estimate parameters, execute counterfactual experiments that show that in the context of our research, the best time to pre-announcement future tax rises is 2 months in advance, and it can enhance the total welfare of the market by 10%. Okay. So I will just briefly introduce our contribution about the literature. The first contribution is that we propose a new policy tool as a way to enhance policy efficiency. In the past, many literature have highlighted that behavioral economics or behavioral bias should be considered when we make policy, and we highlight that we can further enhance policy efficiency by manipulate the pre-announcement. Okay. And second, we highlight that we successfully just embed limited memory effect into a dynamic discrete choice model. In the past, especially the literature on behavioral economics, they usually further propose a theoretical framework about limited memory, and then just justify their story by doing experiments. But in our paper, we just show that such a framework can be combined with the discrete choice model, and we can identify the classical parameters in this kind of limited memory effect through our field data. And finally, our paper is closely related to the field of tax misperception. Past tax misperception paper usually build on a static framework, and we just extend their work to add dynamics to the household's decision. So there is a background about the tax changes in China. Our research window is from 2014 to 2018 and December. And throughout our research window, the government first exogenously lowered the tax rate of the green line, I mean the small displacement vehicles. That means vehicles with cylinder capacity lower than 1.6 liters. So cut down their vehicle purchase tax rate from 10% to 5% here. But the rate for the large displacement vehicles is maintained at 10%. So tax holiday begins. And when the time comes to, I mean, the December of 2016 here at second vertical line, the government announced to the market that it will just increase the tax rate of the vehicles to 7.5% 1 month later, just as January 2017. And a year later, at the January of 2018, the government will further increase the tax rate to 10%, just the same as before. So we can see here that this is the first tax cut, and it is implemented exogenously. And later, from the second line here, it announced future 2 tax rises. So at the first tax increase here, it has 1 month of pre-announcement in advance. And for the second, it has Thanks. So here we just employ a dynamic discrete choice model here, and we follow Gori-Sankara and Reisman's way to show the framework and how we deal with the information set and some state variables techniques we use. So first, we introduce the flow utility here. When a household in China, we just think that their flow utility when they purchase a vehicle is composed by several elements. First, UIJTK here represents a household's I. Suppose it purchases a vehicle J at time T. Its utility will be shown as zeta, lambda, and theta I. And K here represents the vehicle ownership of the households. Suppose that a household owns no vehicle here, K will equal 0. But if it owns some, for example, Benz or Volkswagen, then K will equals the different values here. And the first term is about this utility from purchasing a vehicle, and it's related to price and price heterogeneity. YIT here is about income, so we also consider the heterogeneous demand associated with income here. Lambda JT has 3 terms. One is FT. It captures the microeconomic trend And number J is a model level fixed effects, because CJT is something that we cannot observe or cannot explain in our setting. Theta I captures some willingness to pay for specific vehicles of each household. And epsilon IJT is just a type 1 extreme value distribution, and we can just reach some probability formulas later. Okay, but when a household already own the vehicles, its utility flow will be different. For instance, in here, we assign J equals 0 here because it means that the household do not purchase a new vehicle at time t. So its utility will be determined by K. Suppose its ownership with the vehicle is model K, then it will enjoy the utility brought by K, which is captured by the fixed effect number K here, and also enjoying FT and say KT here. And we allow it to have its endowment or preference for car. So that's captured by sigma nu IC here. Okay, so next we switch to the value function. So to model the response of households in response to the future tax rise, we just employ dynamic discrete choice, and we want to write how their expected value or present value of their utility when they make the purchase. So here we write out two kinds of expected value function. The first one is about the present value that given the information set I. So the state variables we consider here is three parts. The first one is DI. DI includes something like the income of the household that we observe in the data, and also the heterogeneity that is drawn from normal distribution. KIT plus 1 means the ownership or the state variable in there of vehicle ownerships. And IIT plus 1 means that how the households perceive the future market will be. For instance, the I is the I signifies the information set. Suppose that the government pre-announce a tax rise in advance, such an information will be captured in the markup or the transition matrix from IIT plus 1 to future IIT plus 2 here. So its present value is just a combination between its flow utility and future value functions discounted value here. And households have to decide that their which model to maximize their utility. And finally, we write the value function here as a expected utility over all vehicles before they observe their idiosyncratic taste shock. And secondly, we assuming another way here that suppose that there is some households in the market that is completely myopic here. So their information set is represented by I tilde. I tilde means that households do not aware of future tax rate rises. So we write it again. So suppose when households behave like the first one, it's purely rational, so it will take the future tax rises into consideration, and they will just make some stockpile choice decision. For instance, just purchase a car before future tax rises. And for the second case here, it means that the households just forget about the future taxes completely, and they will perhaps miss the deadline to purchase a car at lower tax rate. And usually speaking, such a framework will encounter the curse of dimension, and it's very hard to solve. So here we borrow the assumptions that is inclusive value sufficiency assumptions proposed by Gorsanka and Reisman here. And we use expected utility conditional on purchasing as a sufficient statistic to forecast the future status. And this inclusive value is further assumed to follow the markup process here. So with such assumptions, we can just replace the information set IIT with the delta IT. And that just reduce the high dimension in the information set to just one dimension. And here we made a further assumption that is related to some behavioral economics here. We assume that households' real decision is a convex combination between the rational value function and the naive value functions here. So under such framework here, we just get a lot of Bellman equations. So these equations will govern the determination or the process of how households anticipate future markets will be and make their purchase decision. One thing to mention here is that in the original work of Gorsanka and Reisman's paper, the inclusive value sufficiency assumption is made in the steady state or the stationary stochastic process. But here, the Markov process is influenced by the pre-announcement for the future anticipation. So if the household's information set is struck by the future tax rise announcements, I assume that in their belief, they will reach into the stationary status instantly when the tax rises has been implemented, and they later use a backward induction way to just derive their current utility. I mean, delta IT and EV here. So here we just reached a classic probability choice here that's represented by equation 10. And here we make some further integrations that can let us know the market shares from the micro individuals choice probabilities here. We first integrate over PDIT. That means that we consider different kind of household heterogeneity here. And later, because in our model, different households might have different vehicle ownerships that will influence their purchase decision. So we also integrate over RCT. That means their potential probabilities and the different kinds of vehicle ownerships here. And we assume a static supply part here, but we also consider a dynamic one later to further validate our model. And here we also consider the tax influence on the final after-tax price that is owned by the by the manufacturers here. Okay, so the data sets, we use three kinds of data sets. The first is from the CAM, that's the registration or transaction data, and our data further extend to 2007 to just compute how the vehicle ownership probabilities of households. And second, we just scrape data, especially the label price data from autohome.com. That is a platform, and it asks many car owners to report their real price when they purchase their vehicles. And finally, we utilize CHFS, which is a survey data, and it has some national income distributions. So we can use it to calibrate the heterogeneity across income or other factors. Okay, here is a trend of the sales of both small vehicles and large vehicles here. And the first vertical red line just represents the tax cut exogenous rolled out at October 2015. And the second line is the time when the government just released announcement that there will be future two tax rises. One is at January 2017, and the second is at January 2018. Several takeaways from here is that when the households know the taxpayer announcement 1 month in advance, the bunching we observed here is significantly higher than the second time. So we just trace the reason behind the pattern, and then later we do some theoretical framework here. So in our model, there are many parameters to estimate and calibrate. We will just introduce and stress the identification of the two essential parameters that in our paper. The first is about the price utility parameter. Second is about the limited memory parameter driving the limited memory mechanisms here. So to just estimate the price elasticity, we utilize some cost shifters here. One is a tax rate change from the vehicle purchase tax. As this tax is cut to 5% exogenously in our study window. And later at May 2018, the government further cut the tax rate of value-added tax to 1% less than before. So we utilize these cost shifters to identify price parameters. With the price parameters identified, we've later just used the bunching size relative to the pre-announcement duration to identify the behavioral parameters eta here. Suppose that consumers are perfectly myopic, then we will observe that there should be no bunching or relocation of their purchase over time. Then there will be a flat sales trend in the data. But in contrast, suppose that people might be fully rational. What we observe, bunching size should be in line with alpha that is implied in the rational case. In our baseline model, we just set the time discounting parameter beta equals 0.9, and we also do some robust checks and say that our results are robust even if we vary beta from 0.9 to 95 or other values. Okay, so other instruments and moment conditions are standard as the BLP literature. We just skip them. And we wrap up all the moment conditions and instruments to get a objective function. And we utilize a four-layer algorithm to solve the optimization problem. And first, we use a Bellman equation to solve out the delta function and the value function of EV. After we get the two numerical results of the from the two iterations here, we further iterate over lambda GT just through the standard BLP iterations here. And finally, we update the belief on the Markov process here. And we also strengthen the estimation validity of our estimation by using some tic-tac search to get a global minimization. Okay. And here we get some theoretical analysis based on our discrete choice model here. What we want to study is, should the government give some pre-announcements to the market, suppose that they want to maximize sales or the total social welfare. And at the first, we just minimize the probability to just do not purchase a vehicle during our research window as a proposed policy objective. And under that, we show you that there is a critical point here that is eta prime. So suppose that the rational level of the society is less than 1. If it is less than 1, it should be extend the pre-announcement as long as possible. But if it's smaller than 1 and greater than eta prime, then there should be a optimal time to maximize market sales. And instead, suppose that the eta is small enough, we show that rolling out policy directly without pre-announcement is optimal. So this size of eta prime is very important. And later we just maximize consumer surplus as a final objective, and we show that the formula become even more elegant. Optimal time to pre-announce the policy is a log ratio over the option value channels here and limited memories. So suppose that households are more price elastic, they will get higher option value when we should give further duration of the pre-announcement. And if the limited memory factor or the force is stronger, we should just reduce delta t here. And later we show the model validity. Okay, and column 1 shows our baseline results. We also compare our baseline results with many different kinds of potential models. That is because suppose that we want to highlight our story, some potential mechanisms such as other behavioral bias or market frictions might also explain the pattern in our data. So we compare our baseline with present bias or rational decision and rational anticipation, and also consider some market frictions in column 5. So what is present bias here? Present bias, that means that when households get their value function, they will further discount their future utilities by another discounter, that is eta PB here. So with such kind of decision mechanism, households will usually just procrastinate their decision. So one would expect it to witness a higher bunching size before the deadline. Okay, that's about the present bias. And later we introduce a market friction model. This market friction model is very like to a search model, but with search costs represented by the entropy introduced by the search effort. Okay, so in such a framework, we can convert the unit search cost to the eta f here, and we just transformed the search framework to a generalized IID distribution of the type extreme distribution. And we also estimate the performance of such a model. So overall speaking, we just compile the minimum value of the GMM objective function under different kinds of models here, and we show that our baseline model fits the best. But one may also consider some potential extension models. For example, what if our supply part is a dynamic pricing, or households might be memory decay? That means that they might be rational at first, but their memory or attention to the policy will gradually decay over time. So we also consider other models here. Okay, And in our okay, and there should be another two slides here, but seems I have not been use my updated version of slides. I also can execute some validity tests on how the different models perform over time, because the minimum value of GMM sometimes may imply nothing about the performance of the model. So I just plot the fit list of my model over time, especially to want to show that the model of baseline match the function size of the data part best. Okay. And later we just execute some counterfactual analysis to enhance the policy's influence on the market. And first we show that if we just manipulate time to when the government make such announcements, the market sales and consumer surplus might vary over with the manipulation. We show that 2 months in advance is the best time to release a pre-announcement. Later we try to just remedy households' behavioral bias by sending them reminders. This is done by just assume that households are reminded again about the policy pre-announcement. We show here in the horizontal axis is that to remind the public at the end month. That means that suppose a policy is implemented as December of 2017 here. So should we just announce them again at the January or October here? And such a trend is very in line with our counterfactual analysis before, and we show that if we remind the households later in the year, their purchase will be more rational than before. Okay. Yes. Yeah. How long? That depends on different kinds of objective here. Suppose that you want to maximize sales, it's just 1 month in advance. Yes, but if you consider consumer surplus 2 months in advance, just as before. Okay. So we due to the time limit, I skip something here and just highlight something that way in our conclusion. So in our paper, we just find that there is some behavior bias in household decision, and we identify the level of the inattention level. So we later just further propose another policy improvement direction, and something that is also was further discussion. For example, suppose that sending reminders can make some effects in our society, but there is some also social cost. Because the government also always just want to execute a series of policies in the market. If we just sending too much reminders to the society, the real effect of a specific reminder might decline. So we might not get so much policy effect as in our counterfactual analysis. So that's what, thanks for your attention.
It was not so much of an elephant in the end. Okay, can you hear me? Okay. So hello everyone, my name is Paula Navarro and I'm postdoc at SEMFI. And today I'll be presenting this joint work with my PhD advisors from NHH, Morten Sætre and Mateusz Myslivski. So we're going to talk about externalities, market power, and vehicle taxation. And to start, I'd like to motivate a bit why we're thinking about Norway. But let's see if I can. There. Okay. Yeah, now it's great. So I'll start with Norway, saying why it's relevant, and you've probably heard about Norway and cars. So the share of electric cars, new sales, as we speak, is almost 100% in Norway. But already in 2021, which is the year that we're going to be basing this study, this was very high. So reaching 86. And as you can see, other countries were far below that. So This is relevant for several reasons, and one of them is that this technology has become like a real choice for consumers. People have seen how electric cars work. There is the charging infrastructure in place, so it's really becoming like a choice like any other car. And this brings questions such as how are we gonna change now the taxation system? Taxation system was designed to promote perhaps a bit more adoption, but eventually as new cars become prevalent choice in the market, then it might make more sense to make this system such that we are internalizing the externalities. And this is what we're going to talk about today. And we're going to think also about, are these cars really, like, sometimes they're called zero emission cars, but they're really not. So we're going to think about the taxes that we should also apply to these electric cars. So I'm going to show you a bit like how those cars in our data look like, because it might be different than whatever you're used to in your country. So here we see, for example, the electric range. As we can see, it's very high for electric cars. The average is 384. That's you can go almost anywhere in Norway with that range. It's not a constraint. And then here you have also for the internal combustion engine vehicles that are plug-in hybrids. What's the average range with the electric part? Okay. And as you can also see, the electric cars are also more heavy. And this is because they have the batteries, and the batteries are heavy. And so this is going to be important because weight is correlated with local pollution. And then if we think about how powerful they are, electric cars are slightly less powerful than the average internal combustion engine car that we observe here. And half of them are SUVs, more or less for both of them. And then we have also some statistics on the hybrid and the plug-in hybrid. So as you can see, the internal combustion cars that we observe, a share of them is still has some kind of electric component, so the hybrid or plug-in. And then let's think about prices, because the reason why Norway has been able to achieve this massive increase in electric vehicle sales is also because they have had very generous funding schemes. So here we can see the purchase prices for electric cars, and this is excluding the taxes, obviously. And then you see that if you exclude taxes, they're similar. Electric cars are slightly more expensive. But then purchase taxes, they correct a lot for the prices. So you can see that electric cars face no purchase like registration taxes, but the internal combustion will face a substantial tax. In addition to that, consumers need to think about how they're gonna drive those cars and how expensive it's gonna be during their lifetime. And this is something that we're gonna discuss a lot today here, because our model contains a driving decision and the driving elasticity. So then we can understand how these consumers who are forward thinking in the sense of like they anticipate their expected driving cost, they're going to take this into consideration. It's going to be a static model, but with these forward rational expectations. And so if we look at the cost per 100 kilometers, we see that driving an electric car is much lower cost. So it's the cost of the electricity. And in Norway, a lot of houses have charging at home. Then for the cost for driving an internal combustion, it's much higher. And then if you see also the taxes are also for the electric are the electricity taxes, and for the other ones is the fuel taxation. So that's going to provide part of the internalization of the externality. And we're going to talk a lot about how much should this rate be. Okay, and then finally, I want to mention that CO2 emissions is the main component of internal combustion cars' externalities, because these have like the highest weight on welfare. But then there's also the particulate matter. And as you can see, the electric cars have some more emissions because they have more weight. But again, this is not going to be so big in the end. That's why we're not charged. That's why we changed the title, actually, because the value of PM, like the social cost and the emissions that they have, is not so big to be a relevant component as compared to CO2. So in the future, if we only have electric cars, we'll have to think about this more. But for now, the biggest thing that makes the difference for welfare is the CO2. We don't look at congestion externalities here. But I'm going to explain more in detail all the externalities that we do account for. So the general logic that we're going to be thinking about, and it's not going to surprise you, but is that, okay, if we have a competitive market, we have this equilibrium at QC. If there is a monopoly, this price, like the quantity is going to be lower and the price is going to rise. And then if we introduce the externalities, so here we're thinking about externalities of usage, not of production, then it's going to make the cost of driving higher, and the quantity that we're going to be producing in equilibrium is going to be much lower than in the competitive benchmark, right? But still higher than the monopoly quantity. But what happens is that if you have these externalities and on top of that you tax as if there was like by the value of the externality, then you reach an even lower quantity and an even higher price. So this is like the overshooting the optimum that many papers have thought about this recently, and they have been looking this at different industries, but this is going to be something important for our model of how we determine what should be the tax in this market, because we don't want to be too low if we tax the full externality costs. So we're going to take that into account in the model. So just to summarize a bit what this model is about and what's new, what are the main components, we're going to think that what we want to do is say something about the optimal tax design when there is market power and these imperfectly targeted environmental externalities. And I'm going to explain exactly why they are imperfectly targeted. So market power we just described. The externalities is going to be CO2, NOx, PM, and the accidents. So no congestion. There's some other papers looking at that. And also congestion is usually targeted through the tolls. So that's already addressed in that way. And then we're going to think about these externalities being internalized through the driving fuel costs. Regarding the imperfect targeting, this is something that we think is quite interesting and a bit new from this paper. And this is because, first of all, we're not aware of any other study that has looked at weight so far. And it's hard to measure. It's an externality that is hard to measure, but it's very much correlated with the PM is very much correlated with the weight and the accidents as well. So this is why it's a hard to measure externality. And then the other important part of heterogeneity is the usage. It's coming from the fact that not everyone is driving the same amount. Some people drive a lot, some people drive very little. And we want whatever price we have to take that into consideration so that we are having like the taxi drivers making like the best choice of cars because they're going to use it a lot. Okay. So because we have data on driving, this is something that we can address and that we can look at in detail. So more specifically, like in this paper, what we're going to have these two margins of adjustment. First, we're going to think about extensive margin of like what car should I choose? And that's going to be affected by the car choice model. But before we decide the car choice, the consumer is also going to think, how much should I drive? And this we're going to observe from the data. And we're going to make some estimate of what is the optimal driving for each person, and then incorporate that into the utility function for choosing the car. So you choose the car based on what you expect to drive and other characteristics of the car. Okay. So Norway is a good setting for all of this. And the reason is the tax system. So Norway has had this very generous tax system, and there's a lot of heterogeneity, like differences across the vehicle types. The reason is that the Norwegian taxes are decomposed into many components. So they take into account, like registration taxes will take into account weight, they will take into account like the CO2 components. So this provides us a lot of variation across models. And then in addition to this, as I said, there's high adoption in Norway, so this makes other problems that we had in other settings not be relevant here. And finally, one important also, or something that facilitates the study is that we have all this data on every household or every car that has been bought in Norway for a long period of time. And we can now, in this paper, we're looking at a snapshot in 2021, but we can observe how much those households were driving. So this is important for modeling this heterogeneity in driving. So some of the results, we find that people are quite inelastic to driving costs. So they're not changing their driving behavior so much when the fuel costs are for different fuel cost values, and they are more elastic to car choice price. So we find that particularly for electric vehicles, they're very elastic consumers, whereas for internal combustion, it's much lower elasticity. Our model predicts that pass-through is around 75%. This is like an average. And that Pigouvian taxes are not optimal due to market power, as I explained the logic before. But they actually quite well, like the fuel taxes that the government has put nowadays, they are very good at internalizing the internal combustion cars. They're even overpaying a bit. Whereas for the electric cars, it's not the same. Like they are missing some tax. So obviously our counterfactual is gonna suggest that we should have more internal combustion cars in the road if we only care about internal, like internalizing the externalities. Okay, so to talk about what's the related literature, as I mentioned, there is this part of the literature looking at this externality versus market power trade-off, and there's been a few studies thinking about this in different industries like coal shipping or auto industry here. So you see some examples. And then there's also some other literature that has thought more about taxes in the car industry. So I would say that perhaps the closest study is this Grigolo, Reiner, and Verboven, but their approach is slightly different. They are thinking more about, should we have registration taxes? Should we have fuel taxes if consumers are myopic or not? They do think a bit about mileage because they have like the empirical distribution of mileage, but they don't have a driving model. So it's a slightly different approach. And then the rest of the literature, which you might be familiar with, they think more about production standards because manufacturers sometimes are, well, in every country, they have some production standards that they need to respect for environmental reasons. And they will think about how this is going to be affecting. So in our case, it's different because we're thinking about Norway consumption subsidies. And when you put a consumption subsidy, Norway has a lot of cars, but it's still like a 5 million people country. So it's not going to affect how they're going to start producing the cars. So we're going to be focusing on slightly different things than these papers did. We don't need to, as far, like, for the moment, we haven't really endogenized the product attributes because we don't feel like it's necessary for this case. And then we're also going to contribute to some extent to all of this EV adoption, to understanding substitution and externalities literature. But for the interest of time, I'm not going to explain each of these papers. So just to make sure that the scope is clear and the limitations of our paper are also clear, and my comments that we do focus only on new cars. You could think that, for example, used cars would matter, and also for the welfare calculation, this is going to matter. But if we do want to take this into consideration, we need a scrappage model of how, because you're going to have an old car and you're going to think about if you substitute it or not. It's not something that we've done for the moment. We are considering doing it, but for the moment, it's only new cars. And then, as I said, manufacturers are going to fix their product characteristics and the set of models that they are offering to consumers. And it's going to be a static choice model, but with this forward-thinking consumers that take into account the expected driving costs for choosing what car they want to purchase. And then, yeah, EV technology is mature. And then finally, we don't take into account congestion, noise, or production. Those are other externalities that could be also relevant, but that we haven't addressed here. So, okay, when we think about the externalities, I just wanted to give you some numbers of how important they are. And as I said, CO2 is like, if you think about the external cost per 1,000 kilometers, CO2 would be really relevant for that. On average, we get 28 euros for a bigger car and 15 for a smaller car. Then accidents is also quite big, 18 euros for a 1,800 kilograms vehicle. And then local pollution is a bit smaller, as you can see. So less than €1 for NOx. Also, technology for diesel has improved substantially. So NOx every time is a bit less relevant in the model. And then the particulate matter. I think I've covered actually most of this, but let me just say that this just summarizes the kind of taxes that you give in Norway for the cars. And electric cars, they don't pay registration taxes. They don't pay fuel taxes. They just pay the electricity tax, and they are exempted from 25% VAT. So this is like the big part that makes the electric cars super competitive. And then there's other taxes where they pay like less fees. So moving on to the model, what we're thinking is that, okay, in the model, we have different agents. One is the government. The government can choose what fuel tax it wants to put. And in our model, we're going to be thinking about perfect competition or monopoly. And we're going to think that there's going to be a usage tax. And so the government can put this like usage tax, and this is going to affect the car price. And then the manufacturers, they're going to decide what prices they want to set for the stock of cars that they have. The fuel price is going to be exogenously determined in the fuel market, in the oil market. This is not something that we have to model, but then it's going to be affected by the fuel price that the government is putting. And then the consumers, we're going to be thinking about these consumers that make these two choices of the driving and then the car choice that they want to make. So this is the formula for the driving utility. As you can see in the expectations, we have the discounted driving utility, and then we have the alpha, like price sensitivity, the price of the car, and K is the cost per kilometer of driving. And then finally, we have some unobserved demand shock and the error term. So when we think about, like I've said, that first we choose the optimal driving, and this is because we have a quadratic driving term, so you can find a maximum there. And this tells you that you have like decreasing marginal utility of driving. I'm not gonna go through how the derivation, like all the steps, but basically what you need to know is that the optimum depends on the cost of driving and some preference parameter. So this I'll show you in the end how the indirect utility will look like. But first, let me say something about the data, although I'll be brief here. We have these car characteristics that I described. So we know engine, power, fuel efficiency, weight. You saw it in the first slide. And then we have these owner characteristics. We also know every owner, what municipality they are from, and we order them by centrality. This is our way of like understanding heterogeneity, because we understand that more centrality means like from being very rural area, or urban to rural. So this is going to be important in our model because we're going to estimate kind of different costs, and we're going to have a lot of variation based on the age and the centrality of the person. And then we're going to have the list prices, the battery capacity, and the driving information. Okay, so here I just want to, I'm not going to repeat this too much, but I'm just going to say that we recover our marginal cost from the supply side first order conditions. and that our identification is using these tax parameters as instruments for price endogeneity. Okay. So for the driving model, we're going to think about a specification that contains an optimal driving per spell. And we're going to project driving on the cost and interact that with group dummies. So we're going to identify the relative gamma and E across demographic groups. And this is going to allow us to capture this heterogeneity in driving elasticity. So here you have some of the driving model characteristics, the driving cost, the region, the income, and the interactions. Okay, so for the indirect utility, once we have determined this optimal driving, what we're going to do is that the consumer is going to choose the car. And here you have the optimal value, like already here, and then the rest of the parameters that we use. I will not explain in detail like how we do this, but we allow for like this is based on recent paper to have incorporate more heterogeneity from the income distribution. And we're gonna use a control function for correcting for the endogeneity of the price. Okay. And here you have also the car characteristics and the types of like body type and kind of fuel type of the car. This is some of the characteristics that go into X. And let me say something about the kind of heterogeneity that overall we can estimate based on all of these parameters and our like random coefficients. So in terms of observable heterogeneity, we have this location. Oh, sorry. Then the age group. Here you have some examples. And then the unobservable price heterogeneity is going to be based on the price sensitivity, but also random coefficients based on weight, power, SUV, or electric. Yes. Yeah. We can observe that for every car and owner. So we use that for the first stage. So then like going in more detail in the endogeneity and the identification, we have these instruments, as I said, for the price, which are based on the taxes. And the fuel taxes will interact with efficiency to give us some variation on the per kilometer cost of driving a certain car. And then for the control function, so here you have all the steps. We first regress the price on the tax shifters and take that and put it into the indirect utility function. And then heterogeneity in price sensitivity is going to be pinned down by this within group, like centrality H, substitution patterns, and the price effects are going to be separated from the product Xi by using the exogenous tax variation. So we managed to get to estimation results and welfare, so I'm happy. So as I said earlier, we find very inelastic driving cost per kilometer, 0.44 to 0.5. It also depends on the different regions and centralities. We find elastic car choice to prices, and that's going to be a elasticity of 5 for the internal combustions. Markups are approximately 1/3, so like 30%. And this is similar to other studies that have been looking at that. And then we find heterogeneity in the taste, the unobserved, and the geographic socioeconomic characteristics. And there's large and important heterogeneity in the preference for EVs. So I don't have any table like reporting that. But yeah, that's something important that we find. And then the pass-through is 75%. So with all of this, we do some welfare evaluation for the counterfactuals. And here welfare means the consumer surplus, the profits of the manufacturers, and the tax revenue that you would collect. So in the like baseline scenario, what we observe, the government is having those registration taxes. But then when we'll have the counterfactuals, it's just the government is just going to choose to put a usage tax, the Piguvian taxation. And we have this also adjusted by the marginal cost of public funds, because if we change some of the taxes, then those taxes need to be collected elsewhere. So we're gonna have two approaches: one where we have welfare without this term, and one when we account for this outside option of or like shadow cost for the government. And then the external cost is gonna be the external cost of pollution. So for all the pollutants that I mentioned. So here are our first counterfactuals. This is all preliminary, is likely to change. And first, what we see is that on the top, we have the number of cars in thousands. And then on the bottom, we have the average price. Here we have the electric vehicles. Here we have the internal combustion engine cars. And so what we observe is that when we're thinking about the number of cars, we will have overall much less cars in any scenario that is not the observed one. So this is the observed. Here is like the if there were no taxes with the first best, so like competitive prices, but still like the usage tax, and then here with market power, but the usage tax. So as you can see, there should be like less cars for the EVs, and that's something that comes from the fact that electric cars are very much subsidized in this country. And then if we think about the prices, for the electric cars, what we see is that the prices are very low right now, as what they should be for the other counterfactuals. Then regarding the, this is for the internal combustion here, average price. They are actually similar, but they should be slightly lower in the first best. And then for the internal combustion, as I said, in the observed scenario, we see that the number of cars is very low to what it should be. So we should see more internal combustion cars in the road if we didn't have such a big incentives for electric cars. And for the prices, it's varying slightly depending on the counterfactual scenario. So what we conclude is that there is a tax wedge between the internal combustion and the electric vehicles, which is much larger than justified by just internalizing externalities. And this is going to lead to a choice distortion. So if we think about overall components of welfare, so here we have the consumer surplus, the profits, the taxes, and external cost, and then the welfare under different scenarios. So here is like just computing welfare as the addition of these terms minus the externality. But here is taking into account this the cost of public funds. And here is thinking about that we don't care about profits, because obviously these cars are manufactured in other countries. So the Norwegian tax authority or like the government doesn't really have any interest in the cars profit. So if you think about this scenario, this is how everything would look like. And I'll conclude that for welfare, the usage tax, is always gonna be better than having no tax or than the observed scenario. Then no taxes is gonna give us much more combustion cars. The first best is gonna balance the internal car and EV composition, internalize the externalities. And we also show this scenario with like half a usage tax because of this logic of we don't need to charge the full externality price because there's market power. So we show that how it would look like. And in some scenarios, we find that we would have higher welfare if we'd have half a usage tax. Okay, so I'm going to conclude. So while the current taxes might have had other goals like adoption, for the future, if we only have electric cars, we might have to think about our tax system, incorporating PM and accidents externalities for the electric cars will be important to fully internalize those externalities. And driving is quite inelastic to fuel prices. We plan to do more decomposition of what part of the welfare is being affected by the driving, what part more from the car choice, but this is work for the future. So thank you very much.